Right. I want to first welcome to this session of revision of quantitative analysis. The paper being that of it's the paper that we looked at the other time, that of 2015 November of 27th. That was on a Friday. Now the other time we looked at the question. We looked at question 2, where we explained how differential calculus could be used in solving optimization problems. Yeah. Now today I want us to look at a different set of question. I want us to look at question 1A. And question 1A reads, Star Manufacturers Limited specializes in the production of two products, that is A and B. The two products are A and B. The manufacturer sells the products at a fixed selling price to its customers. The following table shows the requirements for production of products A and B. Now we see that now this kind of question is also found in the unit called operations research, which is found mostly in BCom undergraduate and various other fields that deal with business. And this is linear. This part of linear programming that was introduced in high school under what we call the linear inequalities. Form 4, there was inequalities in Form 2, and then we had it developed further to linear programming, linear inequalities close to linear programming in Form 4. Now here we are told that we have two products basically. We have product A and we have product B. So let me grab a highlighter. I need to grab a highlighter here. So there's A and B. There's A and B. So we see that the materials in kilograms that because in an hour, actually in a particular production session, two products are produced, and we see that the materials in kilograms that product A will consume is 5 and labor hours is 3. That of the materials that product B will consume is 7 kilograms and 4 man hours. So available resources, that is available materials in kilograms, 13,400, and labor available man hours in that particular what we would call shift is 7,800. This. So product A, I don't like this highlighter. I think I just need to, yeah. So product A is sold for 2,080 per unit, whereas product B is sold for this. Is sold for, so this is not even helping me. Is sold for 7,939 per unit. The variable cost of production are uncertain with the following margins of error. So we see that in economics, we have two types of costs. The first type of cost is that which we refer to as the fixed cost. This cost is cost that is irrespective of your volume of production. Even if you produced 0 unit of output, you will still have to pay for the fixed cost. Variable cost is that cost that will be changing. Okay, before I get to variable cost, example of a fixed cost is, say, rent that you pay for a facility. So that is a fixed cost. And variable cost is a cost like, say, varying units of labor to respond to varying needs of demand. So here we see the variable cost of production are uncertain with the following margins of error. Labor hour for product A, we see is 140 with an error margin of plus or minus 10%, and that of material per kilogram we have for A is 236 and for B is 710, and it's both varying between -5 and +5. Now, Star Manufacturers Limited utilizes all the available resources. That means we want the first assumption, that's an assumption that we have already put forth, and we are saying that these manufacturers are engaging resources fully. They are producing optimally. So using matrix algebra, determine the total expected revenue. That's one. Then two, the expected maximum profit. Then three, the expected minimum profit. So having looked at the question as such, then the next thing that I need to do is now to set out on the solution. And so what I'm going to do first is I'm going to grab my, yes, this one, my whiteboard. So I need a new one. I need a new page so that we see how to go about it. Okay, we need a blank. I think for now we need a blank. We start with a blank. So we need a blank. And yeah, we need a blank. And there's something I also need before we proceed. I need it to look like to look exactly like the blackboard, the old school blackboard. So there we are. Yeah, there we are. So first things first, I want to ensure that we are neat. So I'll bring it as such. I'll assume that's the middle. Then I'll pick this one. I think that's better. 4, 4, 4. Let's try 4. 4 is much thicker. 4 is much thicker. 4 is much thicker. Then we have now I think I should go with the green. Let me go with the green. Yeah, that's better. That's better now. Okay, so I'll proceed as such. And now the first thing is to look at part A of the question, bearing in mind that we had okay, here we have let's. I think I should have picked green. Should have picked green to bring the difference. Yeah, it's green to bring the difference. So so we say let X be units of product A. So we say let X be units of A, and Y be units of B, Y be units of B. Then we see from what we are given, from the statement that we have just read, from the resource constraints, we see that we have 5x plus 7y is equal to 13,400. Those are units of materials. That's one. Then second thing that we observe is that 3x plus 4y is equal to 7,800. 7,800. Those are labor units. So these ones we get from the this part here, from the question, because we saw that. So 5x, we see 5x plus 7y is equals to 13,400. Then 3y plus 4y is equals to 7,800, just as we have had them here. Okay, maybe that one does not look like 7,800. So let me make it a little clearer. Yeah, so 7,800, like that. So ideally, what we can do is now to come down here and say, because now we have, this is a 2 by 2 matrix, 5, 7, then 3, 4. This is a 2 by 2 matrix. Then of course we have x and we have y. We have x and y. And that being equal to 13,400. And here we have 7,800. Like that. So these are 2 by 2 matrix. This one here is a 2 by 2 matrix. And you clearly see that this is a different way of representing this, because if I said matrix is multiplied row by column, so that we'll have 5 times x, which gives us 5x, then 7 times y, so plus 7y is equal to this. Then if I come here, sorry, whatever we introduced is not intended and makes it look like we are dividing, yet we are not. So let me see. Yes. Okay, let me just rewrite it. Yeah, so sorry. Yes, now let me just bring it. So this was y, this was y as such. Yeah, so that's what we have. Now the next thing now is we need to work out two values, that is the value of x and the value of y. And for us to do that using matrix algebra, we see that this part here, or rather, let me just use this part here, this one here, no, just this one, 5734 is a matrix 2 by 2 matrix. So we want to find its determinant. We want to find its inverse, because once we find the inverse of that matrix, then we would pre-multiply that matrix by the column vectors of the solution to get values of x and y. So straight away, what I want to do, what I'm explaining is this. What I'm explaining is this here. So 5, 3, 7, 4. See that? But you see, I want the inverse. I want the inverse of that. And I know that to get the inverse of that, first, the inverse will be given by, sorry, the inverse will be given by 1 over the determinant. It will be given by 1 over the determinant. And how do we get the determinant? The determinant is simply 5 times 4, which is 20, minus 3 times 7. So 20 minus 21 is negative 1. So we have the determinant, okay, we have the determinant here as 1 over negative 1 over negative 1. But we then pre-multiply, here. Now we have now we change, we reverse the entries here, so that 4, we reverse and change the signs, so that 4 gets to where 5 is and 5 comes to where 4 is, and give it different signs, but this other diagonal remains unchanged. So what I'll be having here is negative 4, I'll be having 7, here I'll be having 3, and here I'll be having negative 5. These are rules of matrices that you should be aware of, and that's what I have, because what I'm trying to get is the inverse. So how then do I get the inverse? I'll be multiplying. I'll now be, because this is now negative 1, so essentially what I have is negative 1. So okay, I did the opposite. I did the opposite of what I should have done. It is, having changed this, not really the opposite. What I've done is just a confusion. Let me correct it before we proceed. Yeah, for those who have keen, you should have noticed that that's not how it should have been. So we change these entries here. We change these entries here so that 4 is here, but here now we have negative 7. We give them different signs. We switch the other ones, but these ones now we add the negative sign. So this, it will be this. It will be something like this: 4, negative 7, negative 3, and 5. So if we multiply that, then definitely what we end up with is that this, now the entire of this is a negative. So it means where there's a positive, it becomes a negative. So my answer is negative 4, positive 7, positive 3, negative 5. So this one is the inverse. That's the inverse: negative 4, 7, 3, negative 5. That's the inverse. So the next thing that I do, having obtained that, is now I will now seek to specify xy, what xy is. Xy, then I will pick that and say minus 4 as we got it, 3, negative 5 as such, 3, negative 5. Then we realize that we remember the position, the column vector, which we had to be 13,400, and here we had 7,800. So by multiplying these two quantities, these two matrices, where one here is a 2 by 2 matrix and this one is a 1 by 2, because yeah, it's a column vector. So in this case, what we'll be having is that now we multiply negative 4 times 13,400 plus 7,000 times 7,800. If you do that, because it's row by column. So if it's row by column, it means that, let me just pick a different color. Yeah. So row by column should mean that you pick a row a row, this is a row, and this is another row. And this is a column as it is. So it is minus 4 times 13,400. So you would have minus 4 times 13,400 times 13,400 plus, it's going to be plus 7 times 7,800. 7 times 7,800, like that. Down here we have 3 times 13,400. So it's 3 times 13,400 plus minus 5 times 7,800. If you work out this well, what you should get is, upon working that out well, what you should get is that here we have that x is 1,000. Sorry. We have that x is 1,000 and y is 1,200. Y is 1,200. Y is 1,200. Or what is written as xy in matrix form is 1,000, like that. And then this is 1,200, like that. So that's that. So what we have essentially, then what it implies is that we then have that A units is 1,000 and B number of units is 1,200. That's what we have. So we can set out to answer the first part, which is asking us to get the total expected revenue. So I would say that the total expected revenue, that is Roman 1, I'm asked total expected revenue. I would then get revenue. Revenue is given by the units, which is 1,000, and we were told that each unit of A is sold at 2,080. So we would have to multiply it as such, plus, so we have that's the first part of revenue that corresponds to A. Then that which corresponds to B will be the number of units of B times the price of each, which is 79, 39. So if you work this out, what you should get is 11,606,800, like that. This is what you should get as that's what you should get as the total expected revenue in shillings. So it's basically, let me remove this. It's basically 11,606,800 shillings as such. So that is total expected revenue. Next thing that I want to get is because okay, that is the question. Part 1 of the question asked us to get what? The total expected revenue, which we already have as 11,606,000. So the second is asking us to get the expected maximum profit. So how do we get the expected maximum profit? The expected maximum profit, we would first then have to look at the aspect of variable cost per unit at given expected rates. So we would have to consider what labor per hour is for product A and product B, and what material per kg is for product A and product B. So for that reason, we'll be looking at what we refer to as the per unit variable cost. Per unit variable cost. So we see in the question here, we are given that the variable costs of production are uncertain with the following margins of error. So we have 140, and then we have 265, 236, then 710. So what we would do then to get per unit variable cost, because that's the next thing that I need to get, is now just a moment. Yes, now let me get a new one, a new board. Let it be blank. Then I do the necessary as such. Then I bring this. I want to assume that's the middle. Okay. Sorry. So I pick my pen as such and we proceed. So per unit variable cost, so I would start with for A, I will say that it is 3 times 140 plus 5 times 236, which will be, if you multiply this by this, you get 420, plus multiply this by this, you get 1180. Total being 1600. Now for B, because we are working out the variable cost per unit. So for B, we'll be having 4 times 265, 4 times 265 plus 7 times 710, which will give us 4 times 265 should be 1060 plus 7 times 710 is 49. Sorry, is 49. $49.70. So if you add that up, you get 60, 30. Good. You get 60, 30. 60, 30. You get 60, 30. So that is what we have. So per unit variable cost, we have 1600 for product A, and then we have 6030 for product B. So total expected variable cost. So we check, we say now total expected variable cost. And up here we had what we should have said here is that this is per unit variable cost. this is per unit variable cost, per unit variable cost, per unit variable cost. That's what we had. So total expected cost will then be given by, so I would call it expected costs. I'll give it E to mean expected. Total expected cost would then be 1,000, which we worked out, times 1,600 that we just worked out, times 1,200 times 60/30 that we have just worked out. And this gives us, this then should give us that expected total cost is then, if you work this out, you should get 8, you should get 8,836,000. That's what you should get as the total total expected variable cost. Then the expected profit would then be, this one is just an arrow, let it not confuse. I think, let me make it clear so that it's not a big deal. Yes, that one. Yeah, so it's better, it's even good that way. We can leave it as such. So that's that. Then expected profit. So if that is that, then I should say expected profit, would again call it that, use that symbol for profit, would then be expected revenue minus expected cost, which should be, we worked out our expected revenue to be 11,606,800. That's the value we worked out. So, and now we have worked our cost to be this. So that has to be minus, we come here and say 8,836,000, which then gives us, so it then gives us the expected profit. It then implies that the expected profit is the difference between this and this, and that should be, if you work it out, it's 2,770,800. So that becomes the expected profit. And we proceed. So that being the expected profit as required, because the question had required us to get the expected profit. So we see that the expected profit is that. But then the question is the question 2 is the expected maximum profit. So expected maximum profit, we then use the error margins as given. So that would only happen in the event that we have, because we see that the error margin is plus. The error margin we are given to be plus or minus 10%. That should mean that it varies between negative 10 to, it varies between negative to positive of 10. That is for labor. And that of materials is plus or minus 5%. That should mean that it varies between minus 5 and positive 5. It varies between minus 5 and positive 5. So we should then use that to define our new unit costs, because we are considering a situation where it is at its lowest. Now, for us to define the maximum possible profit, we need to ensure that the gap between these two, the gap between these two is as wide as possible. So the maximum profit can only occur where this cost is at its minimum. So we pick the error margin at the minimum, which are the negative sides. So we proceed as, so new unit costs will be sorry, we have to do this again. I didn't want to rub that other one. We may refer to them later, maybe here, or they may serve as reference for future students in our website. By the way, before I proceed, if you want customized assistance with tuition, then we offer it online, exclusively online, unless you want special arrangements. But you only need the right tools, and then we can deliver it online at the comfort of your home. What you need to do is to visit our website. Just type this, just type datalytics. Sorry, it must be clear. Yes, just type datalytics, that's Q, academy.com. Once you click this, you will be home and dry, because there you'll find customized help if you are a student who is expecting to sit for a KASNEB exam, national exam, Cambridge exams, and Excel exams, I4 exams, then you better visit that site so that you get booked. And be assisted by our resources. We have a library of books. We have actually a data bank of questions and solutions that should help you prepare. We also have guided sessions that help you not to go beyond any element of your syllabus. So if you are interested, you want to pass your exam in the first trial, kindly visit this site, and you'll be happy. So that's that. Let's proceed. So here I'll rub this. I'll then rub this. That was not the main reason why we are here. Yes. So now that I have done that, so then new costs will now be defined as, what we had wanted to do is to define new costs, and I'm saying new costs will then be defined as, so for A, again we start by saying for A, no, so I will say for A, we have 3 into 140 that we have, but now times 0.9 plus 5 into 236. I hope you remember where these values are coming from. 236 times 0. Now it is 236, but now times 0.95, which should give us, if you work that out, you should get 1,499. Should get 1,499. And then for B, For B, we have 4 times 265 times 0.9 plus 0.9. This was the error margin, 10%. Now that is taken care of already. Then times 7 into 710 times 0.9 times 0.95 times 0.9 times 0.95. If you work that out, you should get 5675.5. Should get 5675.5. Total minimum cost. Total minimum cost, which I will call C minimum, C minimum, will then be 1,000 times 1499, this one here, plus 1,200 times this, which is 5675.5. So if you add that, you should get the corresponding minimum cost to be 8,309,600. That is the minimum. Then that would then mean that should then imply that the maximum profit, because that symbol represents profit, maximum profit will then be this revenue minus the expected revenue minus the C minimum, which will be, our expected revenue was 11,606,800 minus 8,309,600, which is this value now, which is that value there, this one. Sorry, so that was not supposed to be. Can I see if I can strike out? No, can't rub. Yes, yeah, that's better. Good. So this difference, if you subtract these two, then the expected maximum profit, which is the difference between this and this, the difference between those two will then be, if you subtract them, the difference will be 3 million. You can confirm this using your calculator. 3,297,200 shillings. 200 shillings as such. So that becomes the expected maximum profit. And then there's a part asking us to get the expected minimum profit. That is part 2. Is asking us to get the expected minimum profit. So here we will get the unit costs. We will now consider the unit costs on the higher sides, So for instance, for labor we will now take positive 10%, and for raw materials we will now take positive 5%, positive 5%, and that will give us unit costs. So our unit costs will be, for A, we have 3 times 140 times 1.1 like that, plus 5 times 236 times 1.05, and this, if you add them, if you add these ones, the value that you should be getting is because that should be 462 plus 1239, you should be getting 1701. Then for B now, you'll be having 4 into 265, sorry 265, it is 265 times 1.1 plus 7 into 710 times 1.05. If you work that out again, you should get 6384.5. So total maximum cost, in which case now our total maximum cost, which we refer to as Cmax, will then be 1000 times 1701 plus 1200 times now 6384.5. This gives me Cmax to be, that gives me total maximum cost to be about 9,362,400, like that. So it means that if I add what I get here plus what I get here, that is the maximum cost that I'm expecting. That's the maximum cost that I'm expecting to get. And so expected minimum profit, because the profit here will refer to it as minimum, being that the gap between costs and revenue is narrowed. That's why we call it minimum. So let's just see. Just rub this so that I don't have to create another page. We are almost done. Yeah, so I'll pick this. So we see that expected minimum profit, what I will then call expected minimum profit, what I will refer to as this, will then be R minus Cmax. R minus Cmax, which is then 11,606,800 minus 9,362,400. The difference, which gives 2,244,400. And so that's the expected minimum profit. And we go back to the question, and we see that we were expected to get the total expected revenue, the expected maximum profit, and the expected minimum profit. So we see that in our answer, the answer to part 3, we see that we have already worked it out. Answer to part 3 is this, and answer to part 2 should be this as we add it, as we worked it out. No, this is answer to part 3. I want answer to part 2. Answer to part 2, answer to part 2, answer to part 2. Part 2 required us to get what? So it must be, the answer should be here. We must have worked it out here. Total expected variable cost, and then expected cost we got to be this, and then expected profit we got to be that. But expected maximum profit, we worked it out. As much as I'm just trying to get it so that I show you, you know that we worked it out and we got it. But okay, all the same, we have gone through all the questions. That this is the response to question 1, expected revenue. As we can see, this was we had worked out. So total expected revenue is 11,606,800. Expected maximum profit we worked out to be 3,297. 3,297. That should be somewhere. Just a minute, I'm going to get it so that I show you. We had it to be 3,290 and 97. Well, I can't seem to trace it, the board where it was, but expected maximum profit we worked out to be 3,297. That's a value that we worked out. And then expected minimum profit is 244,400. So those are the three questions that we were expected to work out. So up to there, I want to stop, and we meet next time in my next presentation.